Vertex of a quadratic function. The vertex of a quadratic function either represents the lowest point or the highest point. A quadratic function's graph is a parabola, and the vertex is the minimum or it's the maximum, depending on how the parabola opens. If it opens up, then it's minimum. If it opens down, then it's the maximum. Then it may be important to find out the coordinates of the vertex. If the quadratic function is given in the vertex form, in an earlier video we saw that this is called the vertex form because it's easy to tell what the vertex is. So if your function is this, a times x minus h quantity square plus k, then you can see that there is a right shift of h units and an upward shift of k on the basic quadratic function, which is x square. And x square's vertex is at the origin. So this vertex happens to be at h comma k. So an example, if the function is 2 times x minus 5 quantity square minus 1, then the vertex is 5. It has a right shift of 5 and a downshift of 1. So 5 comma negative 1. So in this case, it's easy to tell, and that's why this is called the vertex form. Now, not all quadratic functions are given in the vertex form. Sometimes you are given the standard form. So if you are given the quadratic function in the standard form, such as this, ax square plus bx plus c, in the standard form, you don't have a perfect square, and then so you cannot tell where the vertex is because you cannot use the transformations right away. So for this, we need to complete the square just as we did in deriving the quadratic formula video. So what I want to do is I want to factor out a and then rewrite this expression as x square plus b over a x plus c over a. Now, even though there may not be any common integer factor for between a, b, and c, but still we want to have just x square by itself. So that's why we want to write a outside the parentheses. In that case, we have to divide both of the coefficients b and c also by a. Now, once we have this, what we will do is we will think x square plus b over a x, the variable terms, and then we will pair these variable terms and then leave the constant c over a outside. And here you notice that the number that completes the square is half of b over a, which is b over 2a. And then you square. So let me add that number that completes the square. So it's going to be b square over 4a square. And we will subtract that, minus b square over 4a square plus c over a. Okay, it's getting complicated, but we will stop right here. And notice, this is a perfect square, which is x plus b over 2a quantity square minus, I have some combination here of a, b, and c. So let's forget that for the moment. Now, if you wanted the coordinates of the vertex, then of course you would need to get that expression as well. But we only focus on the x coordinate of the vertex. So the x coordinate of the vertex happens to be then just negative b over 2a. So let me copy this onto the next page, and you see that I have written, so let me write down ax square plus bx plus c. This is what I started with, and then after a series of steps, I found out that I could write this as x a parentheses x minus b over 2a, sorry, x plus b over 2a quantity square, and then some combination of a, b, and c. So this is going to be some constant. And now this is in the vertex form. So we converted this standard form to vertex form. And what does the vertex form look like? Well, I only got the x coordinate because I did not simplify that side, the constant part. And it has a plus here, which means it would be negative b over 2a. And then I could have, if I did that, then I would also write it down. Now, I don't have to memorize what that would be. I only need to know that the x coordinate happens to be negative b over 2a. And how do I get the y coordinate? Well, I can plug it into the original function and say that this is the vertex. So in the standard form, that's how you can get the vertex of a quadratic function. In the vertex form, it's immediate. You can see h comma k. But if the quadratic is given in the standard form, then you only have to get the x coordinate. You take opposite of b and divide by 2a. That would give you the x coordinate. And you can obtain the y coordinate by plugging the x coordinate. And that is true about every function. If you know the x coordinate, you can get the y coordinate by simply plugging in, because that's how y is defined. It's defined as f of x. So there are two forms for a quadratic function, and we have seen how to get the vertex in both forms. So with that, I have some practice problems, the answers of which you'll find in the video description. So I have 10 problems, and the first 5 are in vertex form. So it's easy to tell what the vertex is for the first 5. And the next 5 problems are in the standard form. So you want to do negative b over 2a and then plug in to get the y value. So that's all I have for this video. Thank you very much. I'll see you in the next one.